So I wanted to take a moment and go over a problem that is similar to a problem that you'll see on your homework. We've been dealing with limits so far in this class, and we have an important limit in front of us, which says if you have the limit as theta goes to 0 of sine theta divided by theta, this is equal to 1. And so we're going to use this information to help us solve the following. We're trying to find the limit in this example as theta goes to 0. In the numerator, I have 1 minus cosine theta all over sine 5 theta. So when dealing with limits, we want to first start out and just substitute in our value and see what we get. And in this case, if we substitute in 0 for theta, we would get 1 minus cosine of 0 all over sine of 5 times 0. So simplifying this, we get 1 minus cosine of 0. So cosine of 0, recall, is 1. So we have 1 minus 1 all over sine of 5 times 0. So 5 times 0 is 0. Sine of 0, though, is 0. And so after direct substitution, we see that we get this form of 0 over 0. So if we see this form, it's an indeterminate form, and we need to go back and we need to start to manipulate this to help it fall out. And so this is where we're going to use this fact that the limit as theta approaches 0 of sine theta all over theta is equal to 1. So as long as that argument of theta or sine of that argument theta is the same as dividing by that theta, then that's 1. And so we're trying to manipulate our argument of sine to be the same as what we're dividing by, or equivalently, we could say that the limit as theta goes to 0, theta divided by sine theta is also equal to 1. Right? Which, if you think about it logically, makes sense. If sine theta all divided by theta, that as theta goes to 0 is approaching 1, then that's telling me the numerator and denominator are approaching that same value. And so it doesn't matter if we flip it, it's still going to be approaching that same value. So we get back 1. Okay, so let's go back here and let's use some manipulation to get what we want. And so looking at the argument of sine in the example that we have, notice that this argument in here is 5 theta. And so I'm trying to get a 5 theta in the denominator of that sine of 5 theta, or by what I had just stated here, this other limit, we can try to get 5 theta in the numerator. So I can't just put that 5 theta in the numerator or denominator. I'm going to need to multiply this, which I call a fancy 1. And so to get a 5 theta in that numerator, I could just multiply the numerator by 5 theta and that denominator by 5 theta. And so let's just rewrite our limit. So we have the limit here as theta is approaching 0 of this 5 theta all times the numerator 1 minus cosine theta, all divided by, I'm just going to rewrite the order, sine of 5 theta, and that is all times the 5 theta. So let's just go here and kind of manipulate this. I can rewrite this product. I have a product in here in the numerator and a product down here in the denominator. So I can rewrite this as a product of 2 fractions. So if I do that, trying to get what I want, I have the limit of 5 theta all over sine of 5 theta times 1 minus cosine of theta all over 5 theta. And so I can use rules and properties of limits. So I have a product here, and so I can break it down as the limit of the first factor in our product. So 5 theta all over sine of 5 theta times the limit as theta goes to 0 of 1 minus cosine theta all over 5 theta. So from that relation that we were just given above, I can say that this limit as theta goes to 0, 5 theta over sine of 5 theta, that's equal to 1 times. So again, let's go back and do direct substitution for this second limit. So if we go in there and we plug in 0, wherever we see a theta, we have 1 minus cosine of 0 all over 5 times 0. So I have a problem again with the second limit that we just took, because I'm seeing that 1 minus cosine of 0, 1 minus 1 is 0 all over my denominator of 5 times 0, which is also 0. So I'm again getting an indeterminate form for that second limit. And so again, I need to go back here and I need to manipulate this. And so a trick to deal with it when we're not dealing with radicals, if there was a radical here, we'd multiply by the conjugate. We're not dealing with something that we can factor. And we have trig functions. So if it's a trig function like this, try multiplying by a fancy one again. And that fancy one is going to be the conjugate of our trig function. So we're trying to manipulate this to look like one of our trig identities. And so I'm going to multiply by the conjugate of 1 minus cosine theta, which would be 1 plus cosine theta. But again, I don't want to change this, so I want to multiply this by a fancy one. 1 plus cosine theta all over 1 plus cosine theta. So I have this 1 times my limit. So 1 times the limit is just the limit. And so I have now the limit as theta is going to 0. Multiplying out the conjugates, I would get 1 minus cosine squared theta all over 5 theta times the quantity 1 plus cosine theta. So I notice here at this point that I have a form of a trig identity. 1 minus cosine squared theta. So recall back in trigonometry, you had that Pythagorean identity that said that cosine squared theta plus sine squared theta, this was equal to 1. And so we could see that if I subtract cosine squared theta on both sides of that equation, you get sine squared theta is equal to 1 minus cosine squared theta. So notice that's what our numerator is, 1 minus cosine squared theta. So we can rewrite that in terms of sine squared theta. So let's do that. So I have the limit as theta goes to 0 of sine squared theta all over 5 theta times the quantity 1 plus cosine theta. So I'm still, if you go and do direct substitution, is going to get 0 over 0. But again, if you see a sine theta in your limit, then try to manipulate it to use this relation that we're given. And so notice that it's sine theta, it's not sine squared theta there. So I could rewrite that sine squared theta as a product of 2 sine theta. So that sine squared theta could be rewritten as sine theta, right, times sine theta all over 5 theta times 1 plus cosine theta. So notice, again, we can rewrite this if we wanted to as a product of fractions. And that product of fraction, I want sine theta over theta, because we know that limit is 1 as theta goes to 0. Theta. Times, well, I still need a 5 down there. So sine theta all over 5 times the quantity 1 plus cosine theta. So again, let's do our direct substitution. Well, the limit as theta goes to 0, sine theta over theta. We know that piece is going to be 1. All times, now go in here plugging in 0 wherever we see a theta. So sine of 0 all over 5 times the quantity 1 plus cosine of 0. Well, sine of 0 is 0 all over 5 times 1 plus cosine of 0 is 1, so 1 plus 1. So simplifying this, I get 0 all over 5 times 2, which is 10. So I'm not getting that form of 0 over 0. I'm not just getting a 0 in the denominator. If it was just a 0 in the denominator, it would be, the limit wouldn't exist. But I know 0 divided by 10 is 0. So this is equal to 0. So we found what the limit was as theta went to 0 of 1 minus cosine theta all over sine of 5 theta and get back 0. And we had to use some manipulation in there to get this to fall out using that special limit that we were given. I hope this helped. And if you have any other questions on homework or how to do certain types of problems, please let me know and I can create more videos like this.